Today, we are going to run an independent samples t-test using SPSS and JASP. The dataset we are using is called D1. All right, for running a t-test, you need a binary variable, a categorical variable. And today we use gender as our binary variable. If you click on the values, see that 1 is for female and 2 is for male. And you need an outcome, a continuous outcome, and let's choose neuroticism. Analyze, compare means, independent samples t-test. And here, your grouping variable is your binary variable. It doesn't need to be binary. It can be a categorical variable with 5 categories, 4 categories. You have to choose 2 of the categories for your t-test. So I send gender here. And your test variable is your continuous variable. Neuroticism, I send it here. But you cannot click OK, so something is missing. You see 2 question marks here. Click on it. Here you have to define the groups for your t-test. You remember that 1 and 2 are the values, 1 for female, 2 for male. So you just enter 1 and 2 here, click continue, and now you can click OK. Okay, first this table is the descriptive table. You have 2 groups, sample sizes for each group, mean and a standard deviation in each group. As you can see, the average neuroticism is higher among females. So the average is 24.0, for males is 21.2. And this is not real data, so we cannot draw any meaningful conclusion from these results. So you see the difference, but the question is it significant? Is this difference really significant, or it's not statistically significant? For that, we need t-test. This table gives you the results of your t-test, but so t-test results starts from here, t to here. So this part is your t-test results. Before that, there is an assumption test here for equality of variances. So this f-test and its associated p-value, these are not t-test. The first thing is to look at this significance level. And if it's smaller than 0.05, this means that equal variances cannot be assumed. So you have to look at the lower row here. And if this is greater than 0.05, if your f-test is not significant, this means that equal variances can be assumed. So you just can look at the first line here. As you can see, 2 t-tests are reported here. So you have to choose between them. Test here tells you which one. In this case, because f is significant, smaller than 0.05, the significance level, we look at this line. Equal variances are not assumed here. So you have a t-value, 3.2, you have a degree of freedom, and you have the significance level here, the p-value. Then you see a value here, which is a difference between the mean of neuroticism between females and males. And also you see confidence interval for the difference here from 1.0 to 4.4. So these are all related to your t-test. So this is your t-value with this degree of freedom. Is it significant or not? It is significant. So your p-value here is smaller than 0.05. So your t-test is significant. What does it mean? It means that this difference here, you can see it here, as well between these two means, this difference is statistically significant. So you can say that females scored significantly higher than males on neuroticism. So it is statistically significant, but we still don't know if it's practically significant. Is it a big effect or a small effect or a medium effect? That's why SPSS gives you the effect size for your t-test. We look at the point estimate and Cohen's d. Let's choose Cohen's d as our effect size. So the confidence interval for your Cohen's d is from 0.15 to 0.69. Is it small, medium, or large effect? I would say this is a medium effect size here. So this gender difference is statistically significant and it's medium in size. Okay, how should you report the result of your t-test? So this is our t-test, right? We have a t-value, a degree of freedom, and p-value. We have the mean difference and confidence interval for the mean difference. This is how to report a t-test. You put the degree of freedom here. So degree of freedom goes here. And this is your t-value. This is your t-value goes here. Your p-value goes here. Mean difference goes here. And then you have 95% confidence interval for your mean difference. These two values, they go here. And your Cohen's d point estimate goes here. You can also include the confidence interval for your Cohen's d after your d value. So this is the general way to report a t-test, independent samples t-test, right? But also it's important to report the descriptive information here. N sample size in each group, mean in each group, and standard deviation in each group. So you will end up with a paragraph like this, where you report your t-test. Also, you report the mean, standard deviation, and sample size in women and in men from this table. Now let's do it in JASP. In JASP, click on t-test and independent samples t-test from the classical part, which basically means frequentist t-test here. Neuroticism goes to dependent variables box, and gender goes to grouping variable. First, we need to check the assumption of equality of variances. So choose Levene's test, like SPSS, and look at the results. It's significant, right? Smaller than 0.05. This means that equality of variances cannot be assumed. So instead of using students, we use Welch's t-test here. And this is the result of your t-test. T-value, degree of freedom, and p-value. If Levene's test is not significant, you would use students t-test, which assumes equality of variances. There are many options here. In JASP, you can get effect size Cohen's d, which is reported next to your p-value here. You can ask for the descriptives table. You can get plots, bar plots in JASP. You get the bar plot with confidence intervals for both groups.